Good morning, everyone, and welcome to the Factiony webinar series. Today, the webinar is to migrate or not to migrate your analytics data to the cloud. That is the question. My name is André de Blois, and I will be the moderator for this webinar for the next 50 minutes. First, I would like to let you know that the webinar is recorded, and the recording will be available if you want to share it with your colleagues. You will have access to the copy of the presentation at the end of the webinar. So we will send you the links, giving you access to the recording and the copy of the presentation. During the webinar, you have the option to ask questions. So please use the questions window to send us your question, and we will answer them at the end of the session. The topic of our webinar today is of interest for organizations evaluating the options to go or not to go with modern architecture, leveraging the cloud for their analytics data. Most of the organizations are more than ever data-driven organizations, and they're looking for ways to improve their agility, to accelerate the time to put in place data environments, to improve the time to market of new features by leveraging the elasticity and cloud services available, and finally, to improve the security and reduce system administration tasks. What you will learn today is the pros and cons of migrating your analytics data to the cloud, the different options available for the migration, and you will see the steps for migrating your data to Microsoft Azure. Let's look at the agenda. First, I will present who is Factiony, and we will cover the why, the what, and the how. So why consider the cloud for your analytics data? What are your options, and how to migrate? And we will follow with a conclusion and presentation of our coming events, and we will have a question period. So during this period, we will answer questions received during the webinar. So do not hesitate to ask questions as we go using the questions window available on your session. And we will terminate with an express survey of one single question. Who is Factiony? Factiony is an elite squad. So we are a professional services firm having the complete range of expertise and the experience to perform all activities related with the delivery of BI and analytics solutions. We have experience in the planning, the architecture, the data modeling, the integration of data up to the creation of Power BI dashboards. We're specialized on the Microsoft analytical platform. Factiony is recognized as a gold data analytics official partner of Microsoft since 2016. Factiony has the know-how and the expertise in the delivery of modern analytical solutions with flexible engagement models. For more details, never hesitate to contact us. The speaker today is Philippe Torres. Hi, Philippe. Philippe. Hi, Philippe.
So you can hear me now?
Yeah, I can hear. Okay. We can hear you.
All right, super, thanks.
So Philippe is a longtime colleague, actually since 12 years by now, and Philippe is the co-founder and partner of Factiony. Philippe has over 30 years of experience in the BI and analytics field. Philippe is well known in the domain, and he did collaborate in the definition and execution of multiple BI and analytical programs for clients in Canada and in the US. On that note, I will hand it over to Philippe. So I will change the presenter to be Philippe. So Philippe, you have the floor.
Okay, thank you. So show my screen, and I'll put this in presentation mode. Okay, Andre, just check so you can see my agenda.
Yep, we can see
Okay,
your
great.
agenda.
All right,
Yeah.
super. So hello to everyone. I'd like to thank you to attend to this webinar. There's a lot of materials in this webinar. It's really packed. So I would welcome you to or invite you to take a look at the speaker notes, not the speaker notes, but take a look at the presentation that will be made available. So the webinar is really talking about the migrating to the cloud, specifically for your analytical data. So we're not going to be covering anything regarding operational applications or SaaS applications, that sort of thing. So it's really more the analytic data and what are the options on Azure. So obviously the cloud is experiencing a rapid growth over the last 10 years. Everybody's really looking at the cloud or has started migrating to the cloud. So most large companies have led the market in this transformation, just like any other technology, really. But there are a lot of advantages for small and medium companies as well. In fact, the cloud really, in my opinion, allows smaller companies to preserve really the agility that characterizes them, even in times of growth and change. So it's possible to do this while reducing the cost of capital and reducing the expertise that's really required to maintain or to take advantage of the data. For example, with advanced analytics, which you probably couldn't do as a small and medium company. In addition, there are certain point of inflection in terms of reorientation, for example, of technological choices, such as, for example, upgrades or major upgrades to your SQL Server databases, or maybe they're not supported anymore, or major updates to operating systems. So that also creates a point of inflection to go to the cloud. It's not only economics. And that point of inflection, just to give an example, there are still companies still using Windows Server 2003, 2008, SQL Server 2005 or 2008. So it's really time to migrate. These versions are no longer supported by Microsoft when deployed on premise. So a cloud becomes an alternative. And if you don't do that, then it's a risk. So there's and we'll talk about also the migration strategies and how to migrate and conclude the webinar. So the advantages of the cloud, this is partial benefits, but the first, in various studies, the first advantage mentioned is always regarding cost, and that's it's simply because there's lots of leverage in the cloud. There's lots of people using it, and so we can leverage the infrastructure over many clients or many subscribers. So one of the main reasons that the capital investment is very small. So you pay for each service, it's pay on usage with fees often being calculated on an hourly basis or monthly basis. And all of this it comes bundled with the high levels of availability and security, and also support options that you can opt for. The cloud also has this innate ability to adjust upward and downwards the sizing of the subscribed services. So that also keeps costs at a minimum. You don't have to over design a service or a platform, for example, on premise, just to be able to support the peak month loads and those sort of things. You can do this very easily on the cloud. You can change it on the fly, usually in a few minutes. Another aspect is the reduction of the workload required for administrative tasks. So a lot of these services, you don't have to bother with the administrative tasks, and it's done by the Azure team, by Microsoft. So we'll see the differences between IaaS and PaaS. Also, as I mentioned, the idea of having or using advanced analytics that many would find difficult to justify economically, especially if you're running, for example, or you're starting to run things like machine learning models. You'll find that you need large processing capacity, computing capacity that you can ill afford on premise, but you can just turn it up on the cloud when you need it, and once you operationalize it, you can quiet the whole thing down. The cloud also allows you to reorganize your data for ad hoc, without investing in a lot of environment configuration, processing time. You can really configure powerful environments in just a matter of minutes and perform the manipulations required and store them in a new format and queries your production environment. So big advantage there. So what it means in the end is that there's a lot of agility to your IT group. You can satisfy requests from your internal requests, external requests, so much more agility. Obviously, there are also obstacle or perceived obstacles to the cloud, and there's a prejudice out there that the cloud computing is not safe. The data is at risk, lack of in-house expertise, and the whole thing about compliance and rules in certain industries. So if we talk about security, I'd bet you dollars to donuts that the major players in computing, whether it's we're talking about Azure today and now, but whether it's Google Cloud Services or Amazon, these environments are inherently safer, and I would even say by orders of magnitude by simply applying a few best practices. And this is in comparison to what you would be able to implement within your organization. And above all, it's the whole idea of constantly monitoring the environment, in addition to be able to offer quick responses in any event of an anomaly. I'd bet you, again, dollars to donuts that it's much safer on the cloud. And obviously, any organization can't really afford a security breach. We saw the whole stories lately in Quebec, in Canada, in the US. So we need to be real careful about that. The cloud firms, including Azure, they're regularly inspected or audited to ensure compliance with the many international standards they adhere to. So it's not even an issue. If there's a standard out there, they probably adhere to it. And interestingly enough, in terms of security, there are internal teams, at least at the Microsoft, they're called white hats. They're mandated to try and break security, while other teams are responsible for developing these mechanics or processes to ward off similar attacks. So, again, I bet you that you can't afford that in your own organization. But it may happen that talking about compliance, it may happen that that legislation prevents you from hosting off-site personal data, but there's nothing preventing you with the same kind of component architecture, applying a different data architecture, so that you can keep the nominative and descriptive data on site and join it with other transactional data at the point of visualization, such as in Power BI, for example. So some of your data, or a large part of your data, would be on the cloud. Let's say the big fact tables on the cloud. This can be joined up with parts of dimension tables that would reside basically on premise. So that's with same components, slightly different data architecture. The argument also of lack of internal expertise is a legitimate argument, but really when you consider the learning curve to properly exploit these data platforms, you see that it is much less abrupt than when supporting the full range of technologies that are required in an on-site environment. So because it's so easy to use, Microsoft makes it so easy to use, and it's intuitive, and so it's really choosing the right components and architecture that's really the name of the game here. But the exploitation or the operations of these applications or services is deceptively simple. So we'll be talking about services in platform mode, and I think you'll understand better what I mean. So let me just move forward. Let's now sort of talk about the option. In the next block, we'll be identifying the main options for storing and moving your data to the cloud. So there are really two broad families of services under Azure, and they're mainly separated by their class of families are either infrastructure as a service or platform as a service. So-called IaaS or PaaS. The distinction between these families is mainly due to the or the distinction is along the lines of the flexibility in how you can parameterize the included services. And also the distribution of management responsibilities between you, the customer or the subscriber, and Microsoft. So in IS mode, you essentially subscribe to the lease of a virtual server. So you have a virtual server running on Azure, and you essentially lease those with several SQL Server images that are available in the Azure store. But you are responsible, you're entirely responsible in terms of management of the environment. So you essentially transfer the server that was on site to a virtual host. It's and you'll read in the documentation or in the literature, you'll read about the lift and shift approach. Well, that's what it is. It's moving your server almost as is to an environment which is now cloud and hosted on the cloud. In PaaS mode, or platform as a service, you're opting for an environment whose management is largely supported by Microsoft. So services for structured data mode platforms, they include really 5 key services. We have a service called the SQL Database Managed Instance. We have something called the SQL Database Simple Database, SQL DB or SQL Database Elastic Pool. We have something called a serverless SQL database. We have a SQL data warehouse also. There's another service, which is the Azure Analysis Services. It's not really the topic of this webinar. It deserves a whole webinar on its own, but it is part of an analytic environment on premise in lots and lots and lots of use cases. So I mention it. We'll see it in the minimalist architecture charts, but it deserves its own webinar. So this would be out of scope today. So if we explore the separation of responsibilities, on the left-hand side of the chart, you see all this management responsibilities, and there might be a few others, but these are the broad classes of what needs to be done for an environment on-premise. So at the very bottom, the network, the storage, the server, all the way up to the P&T or performance and optimization, the data itself, and the application. So this is what you regularly find on-premise. So if we move right, we see what's going on in infrastructure as a service. So we see that the first bottom layers are taken over by Microsoft. So any networking, storage, server, the processing, and the virtualization of these servers is taken over by Microsoft. However, you still manage the operating system, the database engine, the performance optimization, all the way up to the application. So really, that's what's going on in infrastructure as a service. I'll draw your attention now to the third column, which is the Azure SQL Managed Instance of the SQL engine. We see now that the database engine, while database engine isn't going down, is taken over by Microsoft. So the database engine, the operating systems, they're under the responsibility of Microsoft Azure. So to be precise, the regular update of these two components of these components is under the responsibility of Microsoft. But you always have the leeway, the latitude to configure these components as you wish. So as if you opted for the infrastructure mode. So in terms of optimizing the database, you always have the option of optimizing, and you're giving latitude to do this. So you benefit really from the advantages of a platform as a service and more flexibility in configuring the environment. So and at the very right-hand side, you see other types of services such as Azure SQL Database or Azure SQL Data Warehouse. You'll see that those the P&T is taken over now by Microsoft. So it's really it's really truly a platform as a service. You don't even have to bother with the P&T itself. So in an IaaS, as I said, you're renting a virtual server with technical characteristics you want, such as the processor shadowing, the amount of disk space, the network interfaces, the operating system versions, the redundancy of components, the server itself, if you need guaranteed availability. So all of that is something that you can configure. It's essentially equivalent of hosting a service for the server with a guaranteed availability. However, you're responsible for configuration, the SQL Server environment. You need to apply the updates that are made available by Microsoft for both the operating system and the SQL Server. You're also responsible for ensuring that the operation, performing the backups, for example, and the restores, optimizing the performance. But you're limited to the technical characteristics you've chosen. If your needs change, then you will need to consider a new type of server, which is essentially involves a new migration, because it's just like moving stuff from a machine to a new machine, except that it's virtually in the cloud. So the main advantage of IaaS in that case, that you're not responsible for the hardware itself, and so little or no modification to your applications will be necessary. You can port your application as if they were in your environment. There's really no limitation to the version of SQL Server that you can use. But you have the choice of installing your own license or in the subscription mode. You can have, there's a number of images, SQL Server pre-installed images that you can choose from the Azure store. The images are things like, for example, SQL Server version 2017 on Windows Server 2016, SQL Server 2016 SP2 on 2016. So there's a lot of there's 5 or 6 as of writing this. There's 5 or 6 different images that are available, and you just basically pick the one you that's relevant for you. So this is a sort of minimalist architecture chart, but it's still, I think, representative of a deployment on a VM in IaaS mode on Azure. So I won't go through all the blocks here, but to make the migration as seamless as possible, really, you have to ensure that you have a synchronization between your Active Directory and with the Azure Active Directory. That must be in place. It's really simple. You install a piece that's called Azure AD Connect software, and then you can continue to manage your own Active Directory locally, and all the changes will be propagated on the Azure counterpart. So if you create, for example, and there are rules and configurations and things you can do, it's really flexible. But so if you create a new user or a new group or a new security profiles, that sort of thing, those things are going to be migrated or replicated to the Azure counterpart. It's also a good idea to set up a VPN tunnel between your internal network and VPN gateway configured on the virtual network on Azure. So this tunnel it carries transactions for user connections, and also the loading process that's going to source your data from your online sources to the Azure-based data targets. So whether we use the migration assistant, which is a tool I'll talk to you about later on in the presentation, or whether we use the Azure Migration Service that's on Azure, which replicates your data online and allows you to switch over once the replication is completed. So you need this VPN to run this. You can also configure a point-to-site tunnel, which it really allows VPN connections between mobile users and your Azure infrastructure if you need to do that. And then just to the right of the VPN gateway, you find your virtual machine, and optionally the Azure analysis service. Well, we'll talk about that slightly in the upcoming slides. So we just talked about the IaaS mode. Let's talk a little bit about the services available on the platform. So the platform as a service. So as mentioned earlier, in platform of the PaaS family of services, and they offer different degrees of support for common administrative tasks, and they offer also specific functions depending on the desired usage, and we'll talk a little bit about that. So the managed instance option, that's been available for the past few months. I'm going to say 10 months or maybe not 10 months, maybe 6 months. That's in my views, and then we deploy a lot these to our clients. It's one of the more interesting options because it allows migrations with really minimal friction. What I really mean is that the option requires a minimum change to your current configuration to be 100% functional. It is possible because of the additional flexibility you're given in configuring the operating system and the database engine. So there's things you can do in the database engine that you can't really do if you go to another type of PaaS service. So the managed instance allows you to tweak things like caching and very specific SQL Server options that you really don't have access to in other types of platforms. So this flexibility was really only available in the infrastructure mode, but you don't have to resort to IaaS. You can still use the benefits of PaaS while be able to configure to a higher degree the SQL Server itself. So the managed instance is essentially a SQL Server 2017 in PaaS mode. You also have all the available the diagnostic and query management tools that are available under SQL Server. And it's available with a number of cores. So the processing units can be 816 or 24V cores, depending on the performance that you require in terms of processing capability. Other services in PaaS mode. So we have other services such as the Azure database, the simple database, or the elastic database. These two options are normally preferred in the case of a new analytical database use case because there's a good level of compatibility with SQL Server and a certain level of flexibility in the configuration, even if some SQL Server options are missing that you'll find in the managed instance, but you will not find in SQL Database Simple or the Elastic, even the serverless that we'll talk about. So things like agents, for example, SQL agents, linked servers, triggers. If you have code that requires triggers, that's not supported on these services, and certain limitations also regarding cross database queries. So, but I just want to be real clear about that. So in an analytical context, it's really not a disadvantage because there are other ways. Usually in an analytical context, we find things like triggers and cross database joins and things like that. I mean, there's these things are generally extracted out of the processing now, and then they're better handled in an integration service or in a Azure Data Factory with Flow or even within Power BI. So we tend to have a database which is basically triggerless, store procedureless, doesn't have any cross database queries. So in a new implementation or a new port, let's say that would be the preferred architecture. The Elastic database itself is really similar to the simple database, but it shares the processing and storage resources between different database grouped in a pool. I think it's something like 1,000 database within a pool. So the SQL Elastic pools really are really simple and cost-effective solutions for managing and scaling these multiple databases that may have varying and unpredictable usage demands. So they're on all these databases are on a SQL on a single SQL database server, and so they're going to be sharing all these resources at a set price. So it's really for SaaS developers, software as a service developers, really to optimize the price performance for a group of database with a prescribed budget. So that's a typical use case of an elastic pool. It doesn't have all the advanced features, but it's at really a low cost. It's available, I think it's a few dollars per month or something like that. It's really inexpensive. The other one that's interesting also with the other service is a serverless service. This one is interesting because it offers automatic scale up and down of the database computing resources. So the computing resources are calculated in vcores, so you can configure it from half a vcore all the way to 16 vcores according to the load and processing requirements. So, but it's the scaling of it is automatic. We can have also manual scaling in other types of services, but that's done a little differently. It's done with Azure Data Factory, it's done with PowerShell scripts, that sort of thing. So, and the serverless service can be paused when it's inactive. It can be paused between, I think, 1 and 16 hours of inactivity. So all these things are ideal with small databases that is less than 2 to 3 terabytes, or smaller databases less than 2 to 3 terabytes. There's another option which is interesting, is the hyperscale option of the service. That's a use case where you need very large amounts of storage, so more than 3 terabytes of data, and it's appropriate really in batch mode. So if you have a sort of a batch process that requires lots and lots of data, so we may think of I don't know, something like reloading a predictive learning algorithm or predictive model, or analyzing a whole whack of big data, structured big data. So that might be a good option. It doesn't replace the next service that I'll be talking about, which is the SQL Data Warehouse, which is really designed for interactive queries. When you want to query a lot of interactive data, we'll be talking about in the next slide. So all these services have good compatibility with SQL Server. They're not SQL Server. So for example, SSAS and SSIS, they require external services. So we'll talk about integration and analytics, but and the SSRS reports, they require rewriting within Power BI. The SQL Data Warehouse is another service available under PaaS, and it's really a service that's aimed at analytics hosting needs, which typically exceeds 2 to 3 terabytes. That's one characteristic, and then the other characteristic is that read performance is paramount, including complex queries with multiple joins and many where clauses, lots of predicates, that sort of thing. So that's really the sort of the use case, the utilization case for SQL Data Warehouse. It's really a philosophy of divide and conquer. I'm not going to say map reduce because this is not Google, but it's really the same sort of architectures. I used to work for Sybase 25 years ago, and we used to have a something like that. It's really a typical way of breaking up SQL requests, to divide them, and to run them on distributed servers, and then recuperate the results before sending it back to the requester application. So it does this in the case of SQL Data Warehouse. It does this by dividing the processing and storage over multiple distinct processing and storage units, and each of these things that they can include multiple processors. So service can withstand queries against data volume and then the other petabytes, and it still provides optimal response, and really independent of the number of interactive users. The space, the storage space, is charged separately from the processing capacity, which is an interesting model. The cost of storage is according to volume, and it's on a monthly basis. And the processing capacity itself is charged by the hour. And the service can be shut down and reactivated to minimize costs when not in use. For example, if your architecture uses analysis services, so lots of data is in the cube, it's on the cloud, in the cube, in an AS cube, it's likely that you can put the SQL Data Warehouse on standby and after you refresh the data in the analysis by the analysis services after you refresh your cubes. So in the case where SQL Data Warehouse is accessed directly by your users, you'll have to think about keeping the service running for larger periods of the day, but you can use different strategies to keep costs at a minimum. And in SQL Data Warehouse, the CPU, the memory, the I/O, they're bundled into units of compute scale that are called data warehouse units, or DWUs. I mean, it's just a DWU is just represents a sort of an abstract. It's a normalized measure of compute resources and performance. So depending on basically the cost is by DTU, and that's probably a minimum which I don't know about at this point. So again, this is a chart representing what I was discussing, the separation of compute nodes, and there's a control node that receives all the SQL, and it distributes based on the distribution key to the computing nodes, and the storage nodes are separated from the computing node, so we can really herd all the processing capacity that we actually need. So just a few words about integration services, because in an analytics environment, I'm sure there's lots of cases where there are analysis services running within the SQL server. The integration services running within the SQL servers. So what do you do when you move this to cloud? So really, there's two options to execute your SSIS packages. There's you can deploy a SQL Server to an SSIS to a VM using IAS. So that's that's one option. The second option is to run the SSIS packages separately within the Azure Data Factory and integration runtime service. So if I take a look at another minimalist diagram here, and I'll go back to SSIS and the services, but again, you have to make sure that you have synchronization of your ADs, the VPN gateway, VPN tunnels that we talked about. Now, this time, to the right of the VPN gateway, we find what's called an integration runtime for within the Azure Data Service Factory, or ADF. So this is an integration runtime. Really, is basically is a shell, an execution shell that can be called upon by the ADF, the Azure Data Factory, which is basically the services that allows you to synchronize and to flow your data from point A to point B, from point B to C to D at the same time, event-driven, schedule-driven, that sort of thing. It ensures the flow, and within each arrows of these flow, then you can call on an ETL script, you can call on a Python script, you can call on something that's called an integration runtime. So the integration runtime is a shell in which you can run SSIS packages. So that would be another option if you move your data that has your integration services, or you move your environment that has an integration services component to it to the cloud, by keeping your SSIS packages the way they are and embedding them or calling them within a data factory integration runtime. If you're using SSAS, that's a different story. You'll have to provide a service, you have to provide or subscribe to the Azure Analysis Service instance. So because this is a different service that's available under Azure, and these things are not run within the integration runtimes, are run on their own as a separate service. All right, so with a few minutes that are left, I'm just going to talk about how to migrate. So we'll be focusing on implementation options, but this can only be really high level because there's so many different or a wide variety of use cases. So we're really limited to what we can cover here. So I find this chart really useful because it talks at a high level about what needs to go on when you plan to migrate. So the first thing, obviously, is you need to analyze your needs and constraints, and then define the target architecture. The target architecture really set of components that you'll have within Azure and within your site be able to perform the migration and and keep a certain longevity to the migration. Because you don't need to migrate in a big bang fashion or big bang approach. You can migrate component by component, so your migration itself can actually last more than just 2 hours. You can migrate over months. And for each data repository, you need to evaluate the level of compatibility with the target. There are some discrepancies that you may find, which might require some recoding or rethinking of the architecture. Then you can deploy the target platform, and then you select and apply a replication strategy if you're going to replicate the data using replication. And there's a number of tools that can be used to do this, including the database migration assistant. There's also a data movement service on Azure. So there's again, it's called the Azure Database Migration Service. There's the SQL Server Migration Assistant. There's a data migration assistant. There's also a database experimentation assistant. So there's lots of tools to help you out. And then you might want to talk about think about manual migration by backing up and restoring, manual migration of the transactional replication as well. And then you may want to think about your readjusting your load strategy, because if the infrastructure components have changed, you may very well take advantage of more modern, cost-effective ways of migrating your data or moving your data with all the services under the Azure Data Factory. So when you talk about when you think about identifying and characterizing your needs, so it needs to be aligned with your short and medium-term needs. The choice really of the platform depends on the role of your analytical environment. Is it a corporate data warehouse, or is it a departmental data mart, or is it an operational data store? All these characteristics, and all these components have different characteristics, which will guide you to selecting the best component on Azure. Other features are connectivity, security, resiliency level, redundancy levels. All of these things will influence your design choices. Also, we need to consider the how can I say this? The pattern of utilization over time. Is it used consistently over time? Are there patterns of usage, early morning where all the reports have to be loaded and user want access to their data by 9 o'clock? They have heavy query loads at the month ends or holidays. All of these things will influence the choice of the platform. And again, the current load strategy, can we take advantage of the new type of loading that exists? When we talk about the target platform, again, your choice is really all about the limitations and the requirements that your platform may have. For example, if you have a lot of triggers in your database, what's the cost of replacing those versus just moving the whole thing to a VM with a SQL Server with a proper image that will support the triggers? That's an example. We talk about the period of non-interactivity for the user, the presence of SSAS, ETL, ELT loading strategies. All of these things will provide an influence. One of the things that I like to use is the DMA. I just want to show you a real quick example. I'm going off script a little bit here, but I think it's interesting. So this is the database migration assistant. It's a tool that's free of charge, and it's available for you to migrate the database. I'll just show you how simple it is. So let's say I do a test webinar as a migration. So in here I have the assessment type. I want to move a database engine, or I want to move an integration services. My source SQL Server is SQL Server, and my target, let's say I have a choice here, says Azure database. So if I create this, and then it'll ask me for what my server name is. So I'll pick up a local server. I use Windows authentication and I connect, and then I can see a bunch of database here I can move. So I'm going to assess this database, which is the AdventureWorks from Microsoft. And if I start the assessment, so it does a bunch of things. It requires this. It looks at the source data, and then it knows that the target on Azure is a Azure SQL database, and then it'll give me a bunch of recommendations. It looks at okay, unsupported features, for example, the cross. We talked about this. The cross database references not supported. File streams are not supported. For example, here the Azure SQL database doesn't support analysis services, so we need to migrate to the Azure analysis services. So, and then we can. There's also a place where you can have more information about what's going on. So if I click on this, then it'll bring me to the Microsoft page that talks about what is Azure Analysis Services. So that's a really interesting tool, and then you can also even perform a migration, which we won't do here, but that's a very easy way to migrate data from your source data to from your on-premise data to Azure. And then also there's another option, which I won't show, no time here, but we can move the data from the cloud, that is control the process from the cloud rather than controlling it from on-premise, just as I did right here. For SQL data warehouse, there's really no tools that I know about, so you need to become familiar with the design patterns, the anti-patterns, and really support the features that are required. We can help you with that if you ever need assistance. And then when we deploy with the Azure portal, again, that's a whole bunch of things you can read, but again, it's really easy. There's lots and lots of help there to do that. That's just about this slide is about the migration services itself. It's another way to migrate. As I said, it's really control from the platform, where the data is replicated from your sources to the target, and then once the replication is done, there's a bit of catch-up going on for the replicated transactions, and then you can change your applications to switch over a connection string rather than the connection string connecting to your local on-premise servers. Then they'll basically connect to the Azure instances that you selected, and these connection strings, they're automatically generated by the configuration service when you configure one of the past platforms. So you generate the connection string and you plug this in your application instead. So as a conclusion, should you migrate your analytics data to the cloud? I have a biased opinion, but well-informed opinion. I think the answer is a resounding yes. There's lots of organizations doing this. Lots of organization doing this for all of these good reasons. And even in the short-term benefits, they far outweigh the short-term investment. So I believe that the answer, migrate or not migrate, is yes. So Andre, I'm done. I'll pass it back over to you.
Hey, thank you very much, Philip. You have shared your know-how, and you gave us a good portrait of on migration possibilities, and we heard a lot of good hints about transitioning the data to the Microsoft Azure technologies. And actually, there are plenty of questions, and we can understand that there are plenty of questions regarding technology components that need good decision to be taken. And good decision and good migration steps are key for a successful migration to the cloud. Just before to go to the questions, I just want to let you know that we organize events on a regular basis. So our next event is on November 4th. It's called Dashboarding Day. It's a one-day lab on Power BI, and it's held in Montreal Microsoft offices. We also have 2 webinars in French. The first one is about the integration of Google Analytics data from multiple websites by using Power BI. And the other one is how to create an expenses dashboard in Power BI to detect error and frauds. So to know more about our events, do not hesitate to visit our website for details and to register. We receive questions from participants, so thank you very much for your questions. We will take a couple of them, and the ones not answered, we will answer them individually. So let's take a first one. The first one is, how can we monitor automatically Azure usage to avoid billing surprises at the end of the month?
Yeah, so there's lots of ways to do that, but obviously you can monitor what's being billed, there are charts and graphs and statistics, but there's also the possibility of shutting down servers, let's say at 5 o'clock, and restarting them at 9 o'clock in the morning. There's scheduling based processes that you can control, and then there's also limitations that you can provide when you have, for example, elastic pools. You can limit the number of vCores, that sort of thing. So there's a lot of different things that can be done to control this.
Okay, thank you. We received 2 questions related with the performance from 2 different people. So the first one is, should we expect to have performance issues for preparing the data? And the other question is, what about latency issues for end users?
Yeah, so sure, you can expect performance and latency, but that's just a question of revving up the proper architectural components, or perhaps there's you have some serious issues, and there might be something that's not well architected within your solution. But the good news is that we can control these things, and we can increase the various levels of the analytics service or the warehouse itself, or the storage itself. So yes, you can expect them, but it's very easy to change that and to configure and architect the right solution.
Okay, thank you. We'll take one last question. Okay, so in the cloud, can we have this certification that the data does not cross the border?
Yeah, so there's a lot of regions. The cloud, the Microsoft Azure cloud, has the concept of a region where your data is stored. So when you configure services, you can say, okay, I want these services to run in this region. And so if there's issues with cross-national boundaries, things like that, then you can make sure that your data stays only, let's say, in Canada, or stays only in certain national geographies, and that's completely controllable when you subscribe to the service. You just basically say in which region you want that. You may have different costing components, but you can completely control that.
Thank you very much for the one who asked questions. For the question not answered, we will answer them individually. Thank you, Philip, for the answers. So now it's the